In this lesson, we will continue looking at the collection data structures in Java. Specifically, we'll talk about vector, stack, queue, and priority queues. So looking at the overall UML model, we will find a vector right here, right? So this is the collection root interface, and with a collection of interfaces that extend that. Then we have some abstract classes that do partial implementation. Then we have concrete classes. So you have vector right over here. You have stack next to it. You have queues as interfaces with implementations provided by some concrete classes. And then you have a priority queue right here. So let's start by talking about vector. Now, vector is a subclass of abstract list, right? And vector is equivalent really to array list, right? The difference between the two is that it contains thread safe or synchronized methods. So if you're using threads, it is better to use vector. But if you're not doing multi-threading, array list is a lot more efficient, right? Now, this is an older class, right? It predates Java Collections Framework. So it's got some old style methods that were retained. For example, it's got add element, right, there for backward compatibility, but it's essentially it is the same as add, right? It's got elements that returns an enumeration, which is a predecessor to iterator, some older stuff there, right? Now let's talk about stack, right? Now stack is a subclass of vector, as you can see right here. It also predates Java Collections Framework and also retains some old methods, right? Empty is the same as isEmpty, and search checks if an element is in the stack, right? So it's got some old stuff there for compatibility reasons, right? Now in stack, the peek, the pop, and the push methods are supported, which give it the stack semantics, right? And let's talk about queues and priority queues, right? Now queue, as we've spoken about in other lessons, is a first in, first out data structure. The first thing added to a queue is removed. So first person to get in the queue is the first person that is removed from the queue or gets to leave the queue, right? So elements are removed from the beginning of the queue and are appended to the end of the queue, right? Now priority queue extends the concept and adds priorities, right? And an element with the highest priority is removed first, right? Now queue is an interface and it extends collection. So where does it appear? It might be useful. It's right here, right? And it extends collections. That's where it's sitting, right? And has the following methods, right? So with queues, you hear offer, which adds an element to the queue, right, to the back of the queue. Poll removes and returns the head of the queue, and it returns null if the queue is empty. Remove removes and returns the head of the queue. Now the difference here is it throws an exception if the queue is empty, whereas poll will return null, right? Peek is returns the head of the queue but doesn't remove it, right? And returns null if the queue is empty. Element returns the head of the queue but throws an exception if the queue is empty. So it's, these are paired up. One has exception throwing, the other one has returning null, right? Now, the other one we want to talk about is deque, right? It's pronounced deque, and it extends the queue interface. Let's see where it shows up. It shows up right here, right? It extends the queue interface. Now, what is deque? Deque is a double-ended queue, right? Where you can add and remove elements from both ends, right? Now, linked list class implements the deque interface and is the ideal one we end up using for queue operations. So, the deque and queue are interfaces, they are not concrete classes ready to be used. So I mean, how are you going to get that? You'll notice that the first thing that implements this concretely is linked list, and that's what you end up using to implement queues and deques. All right. So now the deque interface, adds some methods. So it add first, remove first, add last, remove last. That makes sense. Get first and get last basically get it, but they don't remove it, right? Do anything. Okay, so let's look at what this might look like in code. So here you are creating a queue, but you're using a linked list to create it, right? And you are adding strings to it, and we are basically looping through, removing elements and printing them, right? So since it's a queue, they should be removed in the order that they were added, and hence you would get Oklahoma first as it is added first. Okay, we can try this out in code real quick. Let's copy this. And we'll fire up IntelliJ and paste it here. And let's run it. So, we're printing what we expected it to print. It should print in the order that things were added to the queue. Okay. Now, the other type of queue is called a priority queue, right? And by default, the elements are sorted using and kept sorted using comparable, right? So if you create this queue and you keep putting things in there, it's going to be kept in a sorted order based on comparable, right? With the element with the least value at the head of the queue and removed first, right? So alternatively, you can give it, you can create it by giving it an initial capacity of how many elements should be kept in this queue, and you can give it an actual comparator object, right? So let's actually try this out. We'll first create a default queue, and then we'll look at the results, and then we will create a priority queue and see what that looks like. So let's do that. So we'll copy this code for it, and I'll explain it in IntelliJ. So here, so it's missing some import. So let's add those. Now we're good. It's added those. So let's first check what happens when we do this. Actually, it's missing this one as well. Let's fix this. And it should have added collections, and we'll comment this one out. And this may not be what we get, but we will. Let's try this out. So we just have a default priority queue. We've added some stuff, and let's see what order they get put in. So we added Oklahoma, then Indiana, then Georgia, and Texas. It's a priority queue, so it's using the comparable and the compare to keep it in some kind of default order, and it's the lowest priority first, right? So we did this. You notice that Georgia was kept first, then Indiana, then Oklahoma, and then Texas. It's basically alphanumeric ordering with the in ascending order, and that's why Georgia shows up there. And the order is because it is a priority queue. Now, alternatively, we could decide to give it a different way of ordering it, and we could give it a comparator. Now here we have said put it in reverse order, right? And so let's see what happens there. We run this, and now we are getting in reverse alphanumeric. So it is no longer being kept in the order it was added. It is being kept in the order that is prescribed by the comparator, right? Or the comparable interface in this case. Okay, so that has been an overview of some other collection data structures, specifically vector stack queue and priority queues. Thanks.